Sadly, it is time for the conclusion of this course. It is only right to summarize everything we have seen. Once you have completed the course, you can clearly see where everything fits and how much you have learned along the way. We started from the point where we had no idea what machine learning is or how it functions. First, we introduced the fundamentals of machine learning. They were 4 ingredients: data, model, objective function, and optimization algorithm. They were quickly followed by the minimal example. We generated fake data and found the underlying relationship. That was our first major practical example. We proved that machine learning is useful. Immediately afterwards, we explored the same problem, but this time through the TensorFlow framework. While still in the early stages of the course, these topics provided us with a solid foundation of what was to come. Then, we went deeper. We extended our simple linear structure into a complex, non-linear one through activation functions. We saw the most common of them, and supposedly, you practiced on the algorithms we built. We also spent a significant portion of time on backpropagation and its mathematical justification, as it is the essence of the optimization process. Then, we continued by learning about overfitting. For me personally, the concept of overfitting is one of the most interesting topics. Afterwards, we saw and implemented some common strategies to spot the issue of overfitting through creation of the validation and test datasets. Finally, we concluded the section with some useful early stopping techniques and emphasized the fact that we should not only split our dataset, but also apply early stopping when necessary. Next, we went through a short section about the initialization of variables. We backed this up with academic research and continued on to optimizers. We should remember 2 important takeaways from this section. The first one relates to batching and the incredible speed improvement it gives us through the mini-batch gradient descent. The second takeaway was that the learning rate is equally important, but probably a bit harder to come up with. After upgrading it with learning rate schedules and momentum, we reached the state-of-the-art technique, the adaptive moment estimation, known as ADAM. Our final theoretical section touched upon pre-processing and focused on one-hot and binary encoding, as each classification problem requires some encoding. Finally, we went through 2 practical examples. The MNIST dataset was introduced as the must-see machine learning problem. We created some layers, fiddled with the hyperparameters, and optimized the algorithm to get quite impressive results. Along the way, we implemented almost all the topics seen in the course. Only then were we ready to conclude with a business case, which was the true test for the amount of knowledge you acquired throughout the course. Our example was as real life as it gets. We derived a very valuable insight about the company in question and realized that while much better than traditional prediction methods, even machine learning cannot account for 100% of human randomness and client behavior. We would like to thank you for taking the course and congratulate you for completing it. As a token of appreciation, we will take several lessons to introduce you to what's further out there in the machine learning world and what you should look for in order to further improve and broaden your skills. Thanks for watching.